In lesson 6-7, you will use augmented matrix to solve a system of equations. You can use a matrix called an augmented matrix to solve a system of equations. An augmented matrix consists of the coefficients and the constant terms of a system of equations. The coefficients and constant terms are usually separated by a dashed line. For example, if you have this system of equations, the augmented matrix for this system is 1, -3, and then where the equal sign is where the dashed line goes, 8, and then -9, 2, -4. You may want to pause the video and try these two on your own. So in the top row, we're going to have 6, -8, and -10. On the bottom row, -5, and then there's going to be a 0 since there's no y term, and -20. And then for this one, 3, -2, 6, 2, 3, 12. All right, now that was the easy part of this lesson. The next part is a little bit tricky, but once you get the hang of it, it's kind of fun. It's almost like a puzzle. We're going to solve a system of equations using what are called elementary row operations. Basically, row reduction is the process of performing elementary row operations on an augmented matrix to solve a system. The goal is to get the coefficient portion of the matrix to have the form 1, 0, 0, 1, also known as the identity matrix. The three elementary row operations that you'll be using are listed below. You'll want to make sure you have these in your notes. The first one is you can interchange any two rows, or I say swap two rows. Next, you could multiply all elements in a row by a non-zero constant. And then the last one, this one's a little bit tricky, and hopefully after you look at the following examples, you'll understand what is being said here. It says replace one row with the sum of that row and a multiple of another row. So just to review real quick, you can swap two rows, you can multiply one row by a non-zero constant, or you can replace a row with the sum of that row and a multiple of another row. So let's go ahead and try this first practice problem together. The first thing we're going to do is write the augmented matrix. So 2, -3, and then our dashed line, 3, and then this is going to be 1, 1, 14. And remember, we wanted to end up looking like this, the identity matrix. So the first thing I'm going to do, I'm going to swap these two rows so I end up with a 1 in that upper left corner. So I'm going to show an arrow that I'm moving from here to here, and then I'm going to write above that arrow what I'm doing. I'm going to swap row 1, and we'll call that R1 and R2. So now we're going to rewrite it with the two rows swapped. All right, the next thing we're going to do is we're going to go ahead and try to get this to be a 0. I'm going to get this to be 0 right here by multiplying this top row by -2 and then adding it to the bottom row. That's that third elementary row operation, this one right here that I said is a little bit tricky. So I'm going to again take row 1 and multiply it by -2. So to show that, I'm going to say -2 times row 1 added to row 2. Basically, I'm replacing row 2 with the sum of row 2 and -2 times the top row. So let's go ahead and perform that operation. So if I take this top row and multiply it by -2 and then add it to this one, 1 times -2 is -2, and then add -2 to 2 and you get 0. -2 times 1 is -2. -2 added to this row is -5. And then 14 times -2 is -28. And then -28 added to 3 is -25. And then this top row is going to stay the same as it was. So far we have our 1, our 0. The next thing we're going to do is try and get this to be a 1. If you take a number and multiply it by its reciprocal, you always get 1. So we're going to go ahead and multiply row 2 by the reciprocal of -5, which is -1/5. So that first row is going to stay the same. And now I'm going to take each one of these items in the second row and multiply by -1/5. 0 times -1/5 is 0. -5 times -1/5 is 1. And then -25 times a -1/5, or 1/5 of 25, is 5. So now we have 1, 0, 1. The next thing I need to do is get this to be a 0. So if I go and multiply this bottom row by -1, I'll end up with -1. If I add that then to this, -1 plus 1 is 0. So we're going to do that third elementary row operation again, that one that's a little bit tricky. We're going to multiply that bottom row by -1 and add it to the second row, or add it to the first row, sorry. So 0 times -1 is 0, and add that to 1. You still get 1. And then 1 times -1 is -1. -1 plus 1 is 0. -1 times 5 is -5. And -5 plus 14 is 9. And then we're going to go ahead and leave that bottom row the way it was. Now, since we have our identity matrix of 1, 0, 1, 0, our answer to the system is right here. This is going to be 9, 5. The reason why it's 9, 5 is this is like 1x plus 0y equals 9. Therefore, x equals 9. And then 0x plus 1y equals 5, so y equals 5. Now you can still check your work on these problems by taking your solution and plugging 9 in for x and 5 in for y and see if it works in both equations. If it does, you have the right answer. We're going to do one more practice problem. You can choose to do it along with me or try it on your own and see how it goes. First step is to write the augmented matrix. So it's going to be 1, 2, and then 6, 2, 1, and 9. Now we already have a 1 in this first position like we want. So let's now work around and try and get this to be a 0. To get this to be a 0, I can multiply the top row by -2 and add it to that row because -2 plus 2 is 0. So we're going to do row 1 times -2. So -2 times row 1 added to row 2. So this top row is going to stay as it is. But now for the bottom row, we're going to multiply the top row by -2 and add it to that one. So 1 times -2 is -2, and -2 plus 2 is 0. 2 times -2 is -4. -4 plus 1 is -3. -2 times 6 is -12, and -12 plus 9 is -3. So far we have 1, 0. Now we need to get this to be 1. To get a 1, we can multiply by the reciprocal. So we're going to take row 2 and multiply it by a -1/3, since that's the reciprocal of -3. So the top row is going to stay the same. And now we're going to take all elements in the bottom row and multiply by -1/3. 0 times -1/3 is 0. -3 times -1/3 is 1. And -3 times -1/3 is 1. So far we have 1, 0, 1. Now we need to get this to be a 0. To get that to be 0, we'll want to multiply this bottom row by -2 and add it to the top row to get that to be 0. So we're going to take -2 times row 2 and add that to row 1. So once again, that bottom row is going to stay the same. Now we're going to take the bottom row and multiply it by -2. 0 times -2 is 0. Add that to the top row. So -2 times 0 is 0. Added to the top row is 1. Now 1 times -2 is -2, and -2 plus 2 is 0. -2 times 1 is -2. Now add that to the top row. -2 plus 6 is 4. So 1x equals 4 and 1y equals 1. So our solution is 4, 1. And you can check this by plugging in 4 for x and 1 for y into both equations, and it should work in both.